In this video, we're going to cover multiplying 3 and 4 digit numbers by 1-digit numbers using the partial products method and the standard algorithm method. Reminder that multiplication is just a more efficient way to do repeated addition. Looking at the problem 63 times 4, we're going to start with the partial products method. What this means is we're going to find the products when we multiply 4 by the top number 3 and then by the top number 60, because that 6 is in the tens place, meaning that it represents a value of 60. So first we'll do 4 times 3, which is 12, and I just simply write that underneath the multiplication problem. Then I take 4 times 60, which we know 4 times 6 is 24, carry that pattern in of adding the 0. So 4 times 60 is 240. So I just stack that number underneath. Then I add together both of those products. Products are the answer to multiplication problem. So I add the 12 and the 240 to get an answer of 252. Next, we'll use the standard algorithm. So this is that quick shortcut way how we usually solve a multiplication problem. We have 4 times 3 is 12, so I drop down my 2 and carry my 1 this time. And then I do 4 times 6, which I know is 24, plus 1 is 25. And I just drop that down because I don't have another digit to carry the 2 to. Same answer, 2 different ways to solve. We're going to take it up a notch and this time do 259 times 7. So again, I'm going to multiply for partial products my 7 times all of the numbers and their values on the top. So 7 times 9, 7 times 50, 7 times 200. We're definitely going to be using that trick that we can multiply by multiples of 10, 100, and 1,000 to help us do this multiplication pretty quickly. So that first problem of 7 times 9, I know is 63. So I put that answer first. Then I'm going to do 7 times 50, because that 5's in the tens place, giving it a value of 50. I know 7 times 5 is 35. Add on that 0, so 350. Next, I'm going to do 7 times 200. I know that 7 times 2 is 14, and then I need to add 2 zeros this time. And now I can just add these 3 products up, getting me an answer of 1,813. Moving over to the standard algorithm, I'll just do 7 times 9 is 63. This time I'm going to carry the 6 instead of putting it down into the answer. Then I do 7 times 5, which is 35, plus 6 is 41. And then 7 times 2 is 14, but then I need to add on 4 to get me 18. Same answer, 2 different ways to solve. Last one, we're going to take it up even another notch, and this time we're doing a 4-digit number times a 1-digit number. So I'm going to set it up the same way for both partial products and for the standard algorithm. 3,824 times 6. Same thing over here. This time I'm going to multiply my 6 by all of the top numbers in their values. So 6 times 4, 6 times 20, 6 times 800, and 6 times 3,000. Starting with that 6 times 4, I get 24. I just drop that answer straight down. Then I'm going to do 6 times 20. 6 times 20, I know 6 times 2 is 12. Add on that 0. 6 times 800, I know 6 times 8 is 48, and this time I need to add 2 zeros. And lastly, 6 times 3,000, because that 3 is in the thousands place. 6 times 3 is 18, and this time I need to add 3 zeros. go ahead and add up all of those products together. So 4, 4, 9, 12, and then I get a final answer of 22,944. Now moving over to the standard algorithm. I know 6 times 4 is 24. This time I carry the 2. 6 times 2 is 12, plus 2 is 14. 6 times 8 is 48, plus 1 is 49. So a lot of carrying this problem. And then 6 times 3 is 18, plus 4 is 22. And this time I can just drop down at 22 because there's no more digits to carry to. Final answer is the same, just a different way to solve.